And welcome to the A4Q Testing Summit. We're here today with François Martin. He is a big active open source contributor and a member of the Swiss Testing Board. He participates in the working group of the advanced and expert level. Today, he's going to be talking to us about why software testing is a waste of time. A very interesting topic, considering that we have a conference entirely about software testing. So, Francois, please tell me more. Why is software testing such a waste of our time?
Yeah, thanks a lot, Abby. So then let me show you. So first, I cannot change the slides. I think now it works. So first, we already heard my introduction. So I'm a full stack software engineer. I'm working at Karakun. I used to be working as a consultant in testing and test automation. And, as you already heard, I'm a member of the Swiss Testing Board. And if you live in Switzerland and you happen to be interested in, joining as a member, then feel free definitely to do so. So firstly, we have to ask ourselves if software testing is a waste of time. Well, is not testing software an option? So in fact, actually, empirical data suggests that improved software quality results in a better return on investment and a lower total cost of ownership. And you can see the source there. By the way, every time you see a link, you see something that is underlined, it's a link. So when you're looking at the slides, you can just click on it. And on the bottom right, you can see the QR code. So if you want to get the slides, just scan the QR code and then you can see them. And then one question I get asked a lot is, now you have systems like Netflix has, for example, where you have systems that are automatically detecting bugs that are in production. And then when they detect them, they roll back automatically. And, is testing still necessary if this happens? And the answer is yes, in short. So the thing is, users still experience bugs even if they are detected and rolled back. And also, these are just reactive measures. So just like if you're in a car, you don't want to rely on your airbag to be, handling things. You want to make sure that you drive careful anyways. So they just are there to handle issues if they occur, but they are not, thought to prevent them in the first place. So now that we established that testing software in general is not a waste of time, there are certainly things that are a waste of time that we are doing in testing, which this talk is all about. So let's look at test-driven development. So just a quick brief introduction in case you don't know it yet. So the principle behind test-driven development, or TDD for short, is that you add a test first, then you run the test, you expect it to fail, and then you make a small change, the smallest change that you can make that makes the test pass. Then you run the test again, ideally it passes. If it still fails, you make another change until the test passes, and then you start the cycle from the beginning. So you just add another test and so on. And then, so since you just write the smallest code change that you need to make a test pass, you have less tendencies to over-engineer solutions. And by less over-engineering, you also waste less time this way, and the solutions tend to be neater. Another advantage is that the code is automatically written to be testable, since you are starting with the test in the first place. And testable code usually, in my experience, results in good architecture as well, which is another big advantage. And also, according to a report, doing test-driven development reduced the percentage of bugs by a whole 80%, which is quite a lot. So by having less bugs, you also have less time needed to fix them. So by not doing test-driven development, you're also maybe wasting a bit of time. If you're curious, you can learn more about it under this link that you see here. Another one is, probably you all know the test pyramid. So not following the test pyramid can also be a waste of time. So let's look at this test pyramid that you probably all know already. So you see at the base we have the unit tests with the backend and the front end, where the front end is often forgotten in my experience, but is nevertheless as important. You should try to make sure that even in the front end you extract common logic into functions, and so that you can test them in unit tests as well. Then you have integration tests, which you should have less than of unit tests. And at the end, you have end-to-end tests. And as I already mentioned, from the bottom, you have the one that you should have the most. On the top, you have the ones that you should have the least. So you should have the least amount of end-to-end tests and the most amount of unit tests. And the thing is, the reason for that is that end-to-end tests are slow and brittle, meaning they break quite easily. So just if you make a small change, this could already result in the test breaking. And of course, you don't want that to happen a lot. So this is why you should have less of them. And they take a long time to execute since they test the whole stack. And on the bottom, the unit tests and also partially the integration tests, they are a lot faster and more stable. So meaning you can change things and they will not break as quickly, or at least if they do, they are quite quick to fix as well. And if you're curious about learning a bit more, you can see on the right hand, one resource is from Martin Fowler, which is very known in the software development community, where you see an example of the test pyramid and some theory behind it. And also, if you don't have to just believe my words, you can also have a look at this video from Netflix, which I think is quite good, where they mention that they move away from having just 100% end-to-end tests and how much trouble they had with that, and how they learned to embrace the test pyramid. So let's look at an example in practice on how we could apply this. So let's look at a very simple example. Let's assume we have a converter application where we have a backend and a front end. And let's say that we only convert from degrees centigrade to degrees Fahrenheit. And also for simplification purposes, we are only using whole numbers, and assuming that the conversion logic happens in the backend, not in the front end. And the front end accesses the backend via an API. So now what we can do is we can define some test cases. So here you can use boundary value analysis, for example, and then you could get, for example, the following cases on the right that you can see. So as you can see, for example, with minus 274, as that is lower than the lowest temperature you can reach, you expect that in this case, an error is thrown that says the temperature is too low. And in the other cases, you will receive some different results depending on what the input is. And from this point, I would start and implement those as unit tests in the backend, again, test-driven, of course. And then as soon as we have those, we look at what integration tests we would write. So one of them would be a test where we simply pass in a number that returns us an expected response of, for example, here the converted temperature. And this is a case where it works well. And if we look at another case where we test what happens when we have a temperature that is too low, we see that we have a response which shows an error. So these are the only two tests that we should be making in the backend in the integration test stage, because the idea is also behind the testing pyramid that you don't test things multiple times. So here we are simply testing the part that has to do with the integration layer. And if this only has a difference of showing either the converted temperature or an error, then these are the two cases we need to test. And by writing maybe, let's say, all of the test cases again that we had in the unit tests, which is something you also see sometimes, you're also wasting some time to execute them. And now the end-to-end tests. So let's now look at a web frontend that's making requests to the backend. So you see on the left, there is an example of a temperature converter in degrees centigrade. And then you can enter in a text box what number you want to enter and convert. And as soon as you click the convert button, you see the temperature in degrees Fahrenheit. So in this case, 42. So this would be one case I would be testing. I would check when I enter one temperature that results in something that is converted in a correct way. It would show me this. And then the next one would be entering a temperature that is too low. Again, because here in this case, we expect a different outcome from the front end. Here we expect the front end to show a dialog, which shows us that the temperature is too low. And then you would test that when you click on convert after having a temperature that is too low, you would see this dialog, and clicking on OK dismisses the dialog. So here again, you have only those two cases. You wouldn't test all of them again, which also saves a lot of time compared to doing everything again. And another one that can take quite a lot of time is not having enough automation. So we humans are simply not made for executing repetitive tasks by hand all the time. Maybe some of you know the factory scene from Charlie Chaplin. So here you can see, this is, I think, a perfect example of this case where having to execute repetitive tasks is not a good thing for us humans. There are a few reasons to this. On the one hand, it is very time intensive, and this also makes it very expensive, of course. It is error prone because you have to execute the same things over and over again, and you tend to leave out things subconsciously. And also it limits your flexibility in timing for releases. This means you need to have feature freezes and bug freezes and so on. And this really limits you in the amount of times you can release. And also you have a slow feedback loop, which means if something breaks, then you will only notice it quite late, and then it's probably more difficult to fix, which will also take more time. And so by having more automation, you free up time, and it allows you to focus on test activities that require critical thinking, like exploratory testing, which I'm a big fan of. So, and on the other hand, there's also the opposite. You could also have too much automation. So with enough effort, you can actually automate any kind of test case, but this does not mean that you should automate everything. So one example is if you have code, for example, that only runs once, it's probably not worth doing it in an automated way. It's probably easier to just do it by hand. If you have tests without predictable results, then it could also be worth not automating this in this case. And also, if you have code that doesn't have any logic, like you have getters and setters, then this probably is also not worth automating. On the other hand, you could also not run tests enough. So if you have automated tests and you only run them, let's say once a week or maybe daily, depending on how much changes you make in the code. If you make a code change and then you have suddenly a failure, just one day or 1 week later, it could be very difficult to find out which code change exactly caused this issue. But if you run them directly with every, for example, pull or merge request, then you get direct feedback and you automatically see what kinds of issues there are and can fix them before they are introduced. And also, I recommend running automated tests nightly on the main branch. So if you have, let's say, a lot of more smaller applications, like in a microservice architecture, for example, then doing this will allow you to spot, for example, if you have a front end that is breaking because of a new, let's say, browser version that you're using. And this way you can cover that. So, and also you could be running maybe too many tests. So I usually recommend only to execute the tests that are impacted by the code change you make. So especially if you are in a development, then and also in a pull or merge request, this saves a lot of time because it shortens the development feedback loop. If you have to wait 15 minutes every time you run the tests to see if your code change worked or not, this could slow you down quite a lot. And one easy example of this is don't run backend tests, for example, when only the front end was changed, because the front end changing is very unlikely to impact the back end in this case. And if you use Java, for example, there are technologies like the Gradle build cache or the Gradle enterprise predictive test selection that you can use, although the latter is not free. If you use Jest, you could use, for example, the changed since option, which allows you to only run certain tests that have been changed since a certain commit. Or if you use NX, you can use affected, which also only runs tests that are have been changed or are impacted by the code changes. And again, on the right, you can see a reference to a Martin Fowler article again, which explains a bit on how to do test impact analysis. Then one big time waster are flaky tests. So flaky tests are when you run a test multiple times and it doesn't pass or fail, let's say consecutively in the same way. So sometimes it may fail, sometimes it may pass. Probably a lot of you know this. And so usually that requires rerunning the tests multiple times. So usually when you do something multiple times and you expect different outcomes, this is called madness, but in software development, this is called flaky tests. And usually this requires repetitive investigation efforts to determine if tests are really flaky or if they are really a failure that you need to take care of. And this also takes quite a lot of time every time. And also I noticed if you have many flaky tests, then the team starts losing trust in test results, which is also bad, of course, because then they are ignored and then people are not really taking care of them anymore. And one mitigation strategy I found that works quite well is preventing the flaky tests from being introduced in the first place. So for example, if you have new or changed automated tests, you run them 3, 10, or 50 times, depending on the resources you have. And this way you can see, you would expect them to pass in all of those cases. And if one of them fails, you need to fix the test first before it can be merged. And one alternative is to run all of the automated tests multiple times nightly. This, of course, has a trade-off that if you do it this way, you will not get as quick of a feedback, but maybe if you have a very slow test base, this could be useful or at least better than not having it at all, because at least get some feedback as to if you have some flaky tests or not. And again, you have here a resource that you can look at. So one other big time waster are not having data-driven tests. So a lot of you that write unit tests or test in code probably know things like this, where you have the same test case that is almost the same in every case, but you just have different things that are just slightly different. So let's say here you have the expected result that is slightly different and the parameters that you're handing into the add method. But apart from that, it's almost the same. So this is, of course, not ideal, because if you have another parameter, you need to change all of the tests. And if you want to add a new test, you need to duplicate the entire test method, and then you need to come up with a good display name and so on. So people, in my experience, tend to less, they tend to hesitate more when they want to add a new test case in these cases, which is not good, of course. And so don't do this, of course. And then another option is something like this, which I see also quite a lot. So here you do essentially the same, but you just do it in one test case, which you could argue is maybe a bit better, but you still have the disadvantages that this has a lot of duplication. And if you want to make changes, you need to change all of the lines. And also, if you imagine that it's not just one line as it is here per test case, but there are, let's say, 10 lines or 7 lines, then this gets out of hand very quickly. And if you make one change, you need to change all of the 7 lines every time for each test case, which is, of course, taking a lot of time. So also here, another disadvantage is if you run the tests on a CI, so a continuous integration environment, then you may see that, for example, the add test fails at line 30, and then you have to look which line is number 30 again. Is it this one or this one, for example? And this also adds another step that just makes it, you taking more time to investigate the issue that happens here. Yeah, so also don't do this option, of course. And then let's look at how you could do it in a way that is very nice to maintain. So if you use Java, there is in JUnit 5, there is a annotation CSV source that you can use. There you can pass the data either as a CSV inline, as you can see here, or you could also use a CSV file. And then you can see that we only have to write the test once on the right, and then it will apply the different expected results and the different input parameters to it. And by being able to parameterize the name as well, you also have that covered, so you don't need to come up with a name every time. So I noticed you're much more likely to add new test cases if you do it this way, because it's much more easy to do. And then there's another advantage. If you do it like this, you will get a very nice input as well. As you can see on the right, you can exactly see which cases failed. And also one other advantage is if, let's say, one case in the middle failed, if you were looking at the previous approach on the previous slide, then you would have the disadvantage that you would only see that this one is failing. But if, let's say, the last one would fail as well, you wouldn't notice unless you run it again after fixing the first case. And here you already see all of the cases at once which are failing, which makes it much more easy to fix it. And then there's another option, which is at method source that you can use. So if you have, let's say, more complicated arguments, so not only text, for example, but objects or something like that, you can use that method source annotation, where you can specify the name of the method that contains the different arguments. And here again, you can pass as complicated of arguments as you want. Then if you use Spock, you can use so-called data tables, which, as you can see here, displays this in an even nicer way. So, and it's very readable and also easy to extend. And you also, of course, get the nice benefit of having this nice display when you run the tests. Then if you use jest, there is also something like this that is called each. And you see it looks like this, for example. And you see it's all very similar to the previous approaches. And of course, if you use a different programming language, just check it out. Probably there is a different way of doing this that you can use. So now let's look at having too much logic, which is also something I see quite a lot. So if you have a test for a method which is called getPeopleBornIn, which then returns a list of person objects from a database in a random order, then you have a test that maybe look like this. So, and you can see already, if we look at this test, it's quite difficult to understand, and it takes quite a lot of time to also maintain. So if, let's say, your customer comes and now suddenly adds a middle name, you need to add quite a lot of lines here, which makes it more difficult and also more error prone, because maybe you are making some mistakes in the logic. I mean, the reason that we are testing logic in the first place is to not introduce too much logic in the tests, and then risking that maybe those also contain bugs again, which is not ideal, of course. So how you can fix that is, for example, in Java, there is a library called AssertJ, or in Python, there's one that's called AssertJ. From my knowledge, maybe there are more for other languages as well. And you can see this is how you can write the same test that you have seen earlier, just a lot shorter. You can see it's a lot easier to understand what happens, and it's a lot easier to extend. And you can, this really saves you a lot of time if you do it this way. And another advantage is the error output. If you run this test, is very nice. So you can see on the right, it shows exactly what it was expecting, what it found, and what it didn't find. And then you can clearly see, here, there's a bug that returns the name Smith without an H. So you see that here this is very easy to fix the test if you know that this is the error output compared to the other way that you're doing it. And then another one is misusing BDD. So BDD is short for behavior-driven development. We usually specify test cases in a given when-then structure. Usually you also use a framework like Cucumber for this, which adds some glue code to enable you to write test cases in text and then run them in code afterwards. And here I really recommend you to critically evaluate if you're considering to use BDD, if the effort for writing and maintaining the necessary glue code that you need to do is really worth it, because I rarely have seen that this really works out well. And one example I want to show you is the creator of Cucumber wrote a blog post a while back, which you can see here, where he mentions a big problem where he noticed that Cucumber was taken out of the intended context, which was collaboration, so to enforce collaboration between business analysts and developers. And what usually happens, sometimes maybe in the beginning it is like this, but then at some point it turns out that people are just, the developers are just writing all of the tests and there is no input anymore from the business analysts. And at this point it becomes imperative and they lose their documentation value, which also makes them slow and brittle. And usually it's also very difficult to then go back to not having them, which is also a big pain, of course. And then another one is, I noticed a lot of people are having issues with finding the right level of detail to use in those test cases. So here you can see a very nice example by a BDD expert here. So essentially it's about, you're looking for a detail level that is when the user buys a Smurf, and not something like when the user enters Smurf into search text box, then blah, blah, blah. So usually that's the right detail level of going with when the user buys a Smurf, which is rarely used, which also makes the tests more difficult to maintain and so on. And then another one is having inefficient end-to-end tests. Since they are the slowest, you tend to lose the most time here. So I recommend you don't create test data through the UI because that's very slow. I recommend using fixtures like using direct calls to the database or through a backend API, ideally, to set up necessary test data beforehand. And you should use deep links to navigate directly to the page that you want to test, which also saves time and makes the test break less if, for example, a link from a certain page that comes before is not working anymore. You should start the test with the user already logged in order to also save time here, of course, but also not to make the test dependent on the login, except when testing the login, of course. And you should make it possible to run each test spec independently, so you don't need to wait for a different test spec to run before the other one runs. And you should also not wait in predefined time intervals. So probably I've seen it in code where it's just like wait for 2 seconds. If, for example, a condition that you're actually waiting for is already fulfilled in 200 milliseconds, you would already be wasting 1.8 seconds there. So usually it is better to just wait for a certain condition to appear, which is much faster. And ideally, you should aim at each end-to-end test spec not taking longer than 1 minute. It seems a bit extreme, but it is possible. I've seen it work well. And this also makes it very efficient to run the test cases. So another one is not parallelizing tests. So an easy way of speeding up the automated test execution is by just simply parallelizing your tests. So usually I recommend, especially end-to-end tests, to run each test spec and browser combination in parallel on the same machine, if possible, of course, or optionally also across multiple machines if you have a lot of them. And there are, for example, WebDriver IO as a framework, which does this by default, which I can highly recommend for that reason. And Cypress only officially supports it through the cloud that they have and only across multiple machines. So this is a bit limiting in this factor. And you can configure most testing frameworks like JUnit to run tests in parallel. So I also recommend setting that up. Then for the last point, having bad test failure reports makes you also waste a lot of time searching for the right issue, or maybe having to waste a lot of time investigating why it was failing. And I recommend including as much information as you can. And also it helps to include detailed request and response data in the logs. So if you need to check what happened exactly, is it maybe that the front end is using bad data, or maybe that the backend is responding with bad data. And it makes it very convenient if you directly attach application logs to the test failures as well. Of course, this takes some time setting it up, but it is really worth it in my opinion. And in end-to-end tests, try to directly link to screenshots, videos, and page source wherever failures happen, so you can quickly find out where the issue happens. And also, this really reduces the time a lot for investigations, as I mentioned. And another thing I recommend is you use a reporting framework. One I really like is called Allure. And you can see on the right one example of how it looks. And I think it looks quite nice in my opinion. And it's really easy to integrate with a lot of different things. So you can also integrate a lot of different tests. So you have just one dashboard that you can use for everything. So then I thank you a lot for your attention, and I really hope that you learned something today. And now I'm open for questions.
François, thank you so much for such an insightful presentation. I believe we do have a few questions. Our first question is, in your experience, how often does it make sense to do exploratory testing in an agile project?
So exploratory testing is something I really value a lot. So usually what I like is to do it at the end of every sprint, so just before doing the sprint review, or maybe you could also consider doing it after, but I noticed doing it before usually already makes you see some issues that may occur, and you can fix them maybe already if they are critical. And I also often like to involve a lot of stakeholders, as many as possible, which, if you do it well and you organize it in a good way, really makes you have a lot of success in the exploratory testing region. And yeah, maybe you could consider doing it every 2 sprints if you think this is maybe too much, but, just my recommendation, try it. And of course, if you do it every sprint, you have to time box it. So I usually like time boxing it at, for example, 1 hour or 2 hours, and then, looking at the results for half an hour or something. And this proved to be quite effective.
Okay. Our next question is, how would you motivate developers who do not like test-driven development? How would you motivate developers who do not like test-driven development to do it?
So one recommendation from me here is, usually I noticed people who don't like test-driven development, most of the time they didn't try it for themselves. So I just recommend try it, maybe just try it for, I don't know, 1 or 2 weeks and see how it works for you. And also maybe one easy way to get into it is, if you are having defects, then usually this is a good candidate to simply take a look at them and then first reproduce them in a unit test or in a different kind of test, whatever the issue lies. And then as soon as you can reproduce it, try to fix it. This has the advantage that you already have a regression test afterwards that you can use. And by this way, you can get into test-driven development without maybe fully committing to it, and then maybe you can go from there.
Yeah, that makes a lot of sense. I think your presentation was so insightful, and I think introducing exploratory testing into development is a great benefit, especially in an agile environment. François, thank you so much for your insightful session. I encourage our viewers to tune in for our next session on the hour, every hour until this evening. And thank you for joining us today.
Yeah, thanks a lot also for the great organization, and thanks to everyone that joined here.
Viewers, if you would like to vote for your best presentation, visit our website. You can click on François' name in the program, and there is a 5-star panel that you can go ahead and vote for him in the best presentation and best speaker section. Thank you so much, and tune in for our next session coming up in about 30 minutes.